So in this video we'll derive the familiar well-known formula for the solution of the quadratic equation. So suppose we're given an equation ax to the power of 2 plus bx plus c equals to 0. Okay, and we wish to find all x's that satisfy those equations for given a, b, and c. Okay, so how would we proceed into solving this equation? Well, first of all, we may assume that a is not 0, because if a equals to 0, then we have a linear equation which we know how to solve easily. So suppose that a is not 0, then we can divide by a, and this will not affect the solutions of the equation. So we are left with the equation x squared plus b over ax plus c over a equals to 0. Okay. And so how would we proceed from here? Well, we need to remember the formula for the sum of the cube of sum of two numbers. And the idea here is that we would like to get rid of this term here. So if we consider the following expression x plus b over 2a to the power of 2, then when we open it up, this is x squared plus twice x times this, which is b over ax, and plus the other term, which is b to the power of 2 over 4a squared. Now, so what we have here, the way that we can write this is the following. So we can actually replace this part over here by x plus b over 2a to the power of 2 minus b to the power of 2 over 4a squared plus c over a, and this all is equal to 0. So now if we were to switch this to the other side, what we would have is that we have x plus b over 2a squared equals to b squared over 4a squared minus c over a. This equals to that. And now if we bring it to common denominator, we have b to the power of 2 minus 4ac over 4a squared. Okay. And now it begins to resemble something that we already know. So now what we want to do, we want to extract the the cubic root here. Okay, so we're looking for all the x's such that x plus b over 2a would be equal to that expression over here, right? And so when we take the square root of something, of any number here, so the square root is defined as taking the positive part. So actually, when we're looking for all the x's such that x plus b over 2a is equal to that, this means that x plus b over 2a would be equal to the square root of b squared minus 4ac over 4a squared. And since the square root is always defined to be taking the positive part just as a function, that's the definition, because, well, you know, if we were to try to plot the square root of a number, then actually there are two choices. There's the positive choice and the negative choice, that for the sake of definiteness, we ignore the negative possibilities here. Actually, this becomes an interesting subject in the topic of functions of complex variables, when we are encountering multi-valued functions, and so we would say that we're choosing one branch here. So anyway, if we were to take the square root of, say, x squared, of something squared, then this is defined to be as the absolute value of x. So this is the positive part here. So we would write this as, so, but we have here two possibilities. Since we are looking for all the x's such that x plus b over 2a squared would be equal to this, then we have here up to sign plus minus. So we have here two possibilities. So here we need to write b minus 4ac, and here, strictly speaking, we need to write 2a absolute value. But the sign here actually takes care of the possibilities for the sign of a, because if the a was positive, then the sign of a is plus and nothing changes here. And if a is negative, then it flips the sign here, but we are considering the two cases anyway. So we can just say that, x, all the solutions that we're looking for, all the x's that would satisfy this, it is enough to consider just this x plus b over 2a equals plus minus just all the possible signs of this expression, b squared minus 4ac over 2a. And here we can just switch this to the other side, and we obtain that we have two possible solutions, x1 and x2. So this is minus b plus minus the square root of b squared minus 4ac over 2a. And that's the well-known formula that everybody knows how to use, but not everybody knows how to derive. And so for the sake of completeness, I derived it here. And later in this playlist, we will derive the formula for the cubic equation and for the quartic one. So stay tuned.